All right, in this section, we are, it's called Identify Special Quadrilaterals because we are basically bringing all the shapes together we've studied with all of their properties and, evaluating which property goes with which shape and talk about where the overlapping is occurring. So in this very first table, you have all of the quadrilaterals over to the side. And then here are properties across the top. So I want to give you a few minutes to think through this. You're going to place a check mark or an X in each box that is a characteristic of the geometric figure. So as you work through this, I guess you can approach it from the perspective, if that shape always has that property, you would put a check mark. So like maybe on the first, I'll go in a column. If you want to go across the way, you can. That way it might be easier to think shape by shape. But I'll just go in a column on the first one. So both pairs of opposite sides are congruent. Okay, so in a quadrilateral, not necessarily all quadrilaterals, so I'm going to skip that. Parallelogram, yeah, both pairs of opposite sides are congruent. That is a parallelogram property. Maybe I'll do a check mark. Rectangle. Well, rectangles are parallelograms, so that applies in a rectangle. Same process as a rhombus and a square. A kite, that's not true. Only one set of consecutive sides are congruent. Trapezoid. No, not both sets, just one on isosceles, and then isosceles I just talked about. So on the first column, I'm only going to have 4 check marks. So go ahead and pause, see how much of the table you can fill out, and then come back and I'll kind of quickly go over the different check marks. Okay, both pairs of opposite angles. So that is a parallelogram property, so it's going to apply again to all 4 of those. But again, not kite, trapezoid, isosceles, trapezoid. Diagonals are congruent. They are congruent in a rectangle and a square. So because a square is a rectangle, that's why it hits square. Now on a kite, the only one with congruent diagonals are the isosceles. I'm sorry, in a trapezoid. Isosceles trapezoids have the congruent diagonals. Okay, diagonals bisect each other. So when I hear that, that jumps out to me as a parallelogram property. So it applies to parallelogram, rectangle, rhombus, square. On a kite, only one of them cuts the other in half, and then does not apply on trapezoids at all. Okay, perpendicular diagonals. Now that is not all parallelograms. That goes with a rhombus, and since a square is a rhombus, it goes with a square. Also goes with a kite, but no perpendicular diagonals in trapezoids. Exactly one pair of opposite sides are parallel, so that's going to eliminate the top, like no parallelogram, rectangle, rhombus, square. Kite, there are no parallel sides. Trapezoid has one pair, and so does the isosceles trapezoid. Okay, so that goes with those 2. Both pairs of opposite sides parallel. So we're back to the parallelogram group, or that side of your family tree. Parallelogram, rectangle, rhombus, square, and then skipping the rest. Okay, 4 sides. Well, that is a quadrilateral, but all of these are quadrilaterals. So I'm going to check the whole column. All of them have 4 sides. All angles are right angles. So the first thing that jumps out to me is a rectangle. So it's definitely a rectangle, not necessarily a rhombus, but squares are rectangles. But that should be it. Kites, trapezoids, isosceles trapezoids, not right angles. Is it regular? So only some of these are regular. So the only regular quadrilateral is a square because it has equal sides and equal angles. Okay, just equiangular. So just equiangular would be the rectangle because it's 90s plus a square. But that should be it. Equilateral. Which ones have sides that are the same? So rhombus, that's your definition of rhombus. Also squares. But that, I believe, is it. Sum of angle measures is 360 degrees. Well, that applies to quadrilaterals, and these are all quadrilaterals. So this whole column is going to be checked. Okay, so that's what we're going to be looking at, and so I'm going to have more questions in the future for you to sort of work through those ideas, and really having that quadrilateral family tree out might help as well. Okay, number 1. Is there enough information given in the diagram to show that quadrilateral ABCD is a rhombus? Okay, so what I see are angles. So what I see here, I see the 270s and the 270s and the 220s and the 220s. Okay, so opposite angles are congruent. I also see that that angle B here is getting split in half. And angle D down here is getting split in half as well. And the same, I think, is going on with A and C. So if you looked at your properties, that is a property of a rhombus. So I can go ahead, I can't go straight to a rhombus because the only way I can go straight to a rhombus is if I know the 4 sides are equal, and I don't have any information on sides. So I am going to be able to get there with those 2 ideas about it being a parallelogram and then the diagonals or bisecting angles. So is enough information given? Yes. I'm going to say here that both pairs of opposite angles are congruent. Both pairs of opposite angles are congruent. Therefore, it's a parallelogram. Okay. Now that it's a parallelogram, we can talk about the angles being bisected. So I'm going to say here, opposite angles are bisected. I'm going to do some abbreviating with symbols. Opposite angles are bisected by diagonals. Therefore, it's a rhombus. Therefore, it's a rhombus. And so I guess I should, to be 100% correct, I want to talk about why it's not a square. And so because I don't have 90-degree angles, it's not a square. And I'm just going to say not a square, not 90-degree angles. Okay. So the explanation right here, this explanation part is really the point of this problem, not just a yes or no type of thing. Now, sometimes I will ask you a yes or no question. So you want to be thinking through these ideas in your mind as to how you're getting there. That way you can have, the correct answer for whether it is or is not that shape. Okay. Let's go to the next page. I'd like you to go through 1, 2, and 3 and go ahead and give the most specific name. If you want to just right now think of your reasoning, you can. If you want to write it down, you can. But when you come back to the video, I'll probably make a list of my reasoning to get to my answers. Okay. Number 1, I see a 4-sided shape with 4 equal sides. So we can go straight to the fact it's a rhombus. We had, if you look back at your notes on rhombus, rectangle, and square, we had a corollary that said, if you have a quadrilateral with 4 equal sides, it's a rhombus. Okay, so I'm going to say rhombus, 4 congruent sides. And I guess theoretically, it's not a square because there's no info on the angle, so I can't assume that they're 90. So I would stop at rhombus. Okay, I see angles being the same. So if all the angles are the same, I know they add to 360. 360 divided by 4 is 90 degrees. So this is a rectangle for sure. Can I go to a square though? I don't know anything about sides, so I'm stuck at the 90, so I have to stop at rectangle. This is only a rectangle. Okay, number 3. I see one set of parallel sides. This is a trapezoid to start with. One set parallel sides. Okay, now I have this down here. So if these are the base angles, if this is a trapezoid and these are equal, then it's probably an isosceles trapezoid. Can I show that the two stars here are equal? So what I could do, let's just throw an example number on there. Let's just say these are 80. So I know if it's a trapezoid, the angle A is supplementary to angle D, so it's 100. And so if I separately think about this one, 80, this would also be 100, which notice I get them to be the same. So this is an isosceles trapezoid. And I need to make sure I can see that the top two angles are also the same. I'm going to say here, both pairs of base angles are congruent. Okay, so I guess that's my final answer. Isosceles trapezoid, rectangle, rhombus. Okay. Well, if you have questions on any of those explanations or you think it should be something else or want to talk through something, don't hesitate to send me an email.